Okay, so now we see some kind of an examples of the pressure in our daily life. So first thing is, so we had discussed earlier that the pressure is going to depend upon two factors: the amount of force or the thrust acted upon, and secondly the surface area in contact. So more the surface area, lesser the pressure. Lesser the surface area, more the pressure. So let's see that how in our daily life we are reducing the area in contact and hence increasing the pressure. So we see first thing, a nail or a board pin has one end pointed and sharp while the other end is blunt and flat. On applying force, the pointed end will exert greater pressure as the area of contact is small, and hence it will go deep into the given surface. So as I told you about the pins itself, we'll show you the pin once again. So in the pin you can see in this particular pin that this part is broader whereas this part is very thin. So when you are applying the force, so when you apply this force over here, at that time, this being very small, that's why it is easy to drive this pin into any particular thing. Like for example, if I want, I can show you this thing that if I take this eraser and I put this pin and I put it very easily, it can drive into this particular eraser. So this has gone inside very easily. But the same thing, if I to try to put it like this, it is not possible. Why? Because when I am applying a force, this area being very small, the pressure exerted by it becomes very high. So hence this is easy. That's what we are saying, that applying the force, the pointed end will exert greater pressure as the area of contact is small, hence it will go deep into the given surface. So this is how you can see the example of the pin. Secondly, the cutting tools like blade, knife, axe, etc. have very sharp edges. You will always find that the blades, the knife, everything has got a sharp edge. The axe, they always have a sharp edge. Because the sharp edge, what will happen? When you hammer it, the sharp edge is going to give more pressure at the contact area, and more pressure will be able to cut that thing more easily. The sharp edge is a very small area of contact, so the pressure applied by the force is more. All these are very important give reason questions. They can ask you the question like, why is the pin having a pointed edge? Okay, why are the knives have got a sharp edge? Okay, so all these are good examples of give reason questions. So you just have to say that the sharp edge of the knife or the axe have very small area of contact, so the pressure applied by the force is more. Third is, pointed heels of footwear exert more pressure on the ground than the regular flat heels. Therefore, lady with pointed heel sandals find it difficult to walk on a muddy road than on a tar road. It's very easy. Many of you girls who are wearing some high heels and by chance after a party you try to go to the Jew beach, you will find it very difficult to walk with your heels on, because that heels, because they have got a pointed edge over there, it is just going to sink inside, or it is going to just penetrate into the sand. That's why it will be very difficult to walk on in the sand or even in some muddy area with those heels. So you will always see many of the females who are walking on the beaches, they will always remove their sandals and keep they will be the sandals in their hand and then walking, because it will be much convenient for them to walk barefoot rather than walking with those sandals or heels, which is high heels or rather than a flat heels. So that's why you see that pointed heels footwear exerts more pressure on the ground, and accordingly it is more difficult to walk on muddy roads than on a tar road. A tar road, it doesn't matter because tar roads are very hard surfaces, so they don't penetrate into, the heels cannot penetrate into the tar road, and that's why it's easy to walk on the tar road with those heels. Next is, a narrow heel sandal on a girl hurts more than the broad heel shoes of a boy. This is because more pressure exerted by a girl than that by a boy, as her heels is narrow. Now, by chance you are traveling in a bus or some train, and suppose there is some particular lady who is just in front of you is wearing high heels, and by chance that high heels of hers are just resting on your feet, then it is going to give me very very painful experience, because the high heels, maybe she is not having that much amount of weight of hers, she may be very thin, but her whole body weight, the force, the thrust is going to be acting on a very small pointed heel, and hence that pointed heel is going to it is going to give you much more pressure on your feet. If you just happen to be, it just happens that her heels are on your feet, so a narrow heel sandals of a girl hurts more, right? So that's why a narrow, if a man is standing with his flat completely flat heels and on your feet, may not be so hurting, so it may not hurt you much. But if the girl who may not be of the same mass of that of the boy, if she is wearing the high heels and then that particular heels are then on your feet, then okay, it's going to be very very painful. So these are the examples wherein we decrease the surface area and hence increase the pressure what is being exerted by it. Now let's see some examples where we increase the area so that the pressure gets decreased. Since many cases happens that we need to decrease the pressure, because otherwise if the pressure is very high, there are chances that the thing may break. So to decrease the pressure, we increase the surface area. So let's see what are those particular examples wherein we increase the surface area by and hence reduce the pressure. First thing is, heavy trucks have 6 to 8 tires instead of conventional 4 tires. More number of tires are used to increase the area of contact and thereby reduce the pressure on the ground. You must have seen many times the trucks, it's a regular affair, you see the trucks. Trucks, you'll see that there are 4 wheels, but the 4 wheels, if you see carefully, front wheels are only 2, but the rear wheels are 2 each. 2 on one side and 2 on the other side. Even the buses are the same way. 2 in the front, but 4 in the back side. Some buses or trucks are such that they don't have 4 on the back side, they have got 8 on the back side. So set of 4 and another set of 4. Why do we have this thing? This is because as we increase the number of tires, the surface area in contact between the road and the truck increases. So by increasing the number of tires, we are increasing the capacity of the truck to hold more amount of goods. So when the number of tires increase, the surface area increases, so the pressure is going to decrease. Accordingly, the truck will be able to load heavily. Okay, we are able to load the truck much more when the number of tires are increased. So that's why they are given you that more number of tires are used to increase the area of contact and thereby reduce the pressure on the ground. We move further, is a camel can move more conveniently on a sand as compared to a horse. So the reason is quite simple. The camel, if you see a camel, the camel feet of the camel are flat. Okay, they are flat feet. They are completely flat. Whereas the horse have hoofs. Okay, which is like the area of contact is very small and there are hoofs. So they will be like this, like this. Okay, whereas that is flat. Why is it so? Because camel needs to travel in the sand. Okay, it's a desert animal, so it needs to travel in the sand. So when if the camel is given hoofs, then its feet are going to get penetrated into the sand. So they are given flat feet so that they can rest properly on the sand and easily walk on the sand. Whereas horse, if it tries to walk on the sand, it may fall, it will topple, right? Because the hoofs will penetrate into the sand and not allow him to go that fast. So The camel can move more conveniently on sand as compared to the horse. The reason is that camel has broader feet than horse. Okay, the feet of the camel is broader. The broader feet of the camel provides lesser pressure on the sand and it becomes easier for the camel to walk. In the case of a horse, the area of the feet is less, due to which the pressure is more and hence the feet show a tendency to sink inside the sand, making it difficult to walk. Okay, so this is how the camel is able to walk easily on the sand as compared to the horse over here. Next thing is the third thing is a skier use long flat skis to slide over the snow. The larger the area of contact, the lesser is the pressure on the snow. This helps the skier to slide comfortably without sinking in the snow. You know the ski will always be having a flat band. So they're going to be like this, that the person is standing over here and the feet is completely in a flat kind of a ski like this. The ski is like this. So you can see the regular surface area of contact of the feet is only this much, but the ski is giving you this much. So your complete body weight is distributed to a bigger surface area. Hence the pressure exerted on the snow will be very less. Since the pressure exerted is less, hence the penetration inside the snow will be less. Hence the person can easily slide over the snow without getting penetrated into the snow. So that is how the skiing is easier, makes the skiing easier. So that's why we say that the larger the area of contact, the lesser is the pressure on the snow. This helps the skier to slide comfortably without sinking into the snow. Okay. The next is, army tanks are usually very heavy and they exert large pressure on the ground if they move on wheels. Hence, they are made up to move over a broad steel track called caterpillar wheels of tanks. Have you seen a tank? Now, when you see a tank, the tank is like this. So if you see a tank, the tank will be having wheels like this, but these wheels are connected to a broad steel belt like this. So this is a tank. So this is a tank like this. Yeah, this is the tank. So this particular kind of chain is the one which is going to give you a broad area, so that the tank which is heavy, first of all it is heavy, so automatically it will try to sink into the ground. Moreover, the flat part over here will automatically reduce the pressure. Secondly, tank can move around in all places. It can move around on sand, that is deserts. It can move around in marshy places. It can move around in places like snow. So everywhere it doesn't want to sink inside, and hence you have got broad steel belts, so that it is decreasing the pressure and it is able to move easily. So that are called as caterpillar wheels. So that is caterpillar wheels of tank. These tracks are used to increase the surface area so as to reduce the pressure on the ground and hence avoid sinking of the wheels in the ground. So that's it. You can see it will avoid the sinking of the tank into the ground. So this is how the tanks are able to move easily in any surface due to the caterpillar wheels. The fifth wheel is, foundation of building are kept wide so that the weight of the building may act on larger surface area. As a result, it will exert less pressure on the ground. This will avoid sinking of the building into the earth. So you will always find that even when you see a very tall building, you will see that the lower portion, maybe like a mall or something, or maybe like a good shopping complex, or maybe having a very large parking area. Why is it so? Because by giving that particular big area at the bottom and a thin building on top, what you are trying to do is that whatever pressure which is exerted by the building is distributed to a larger surface area. So the pressure exerted by this tall building on the big area will automatically decrease. So force भले बहुत ज़्यादा है, but the area is becoming much more higher, due to which the building will not sink into the earth. This is how the foundations, that is why the foundations of the building are kept wide. Okay, they are wide foundations, and then the building is normally tapered down smaller. Even the Al Burj Khalifa, if you see, what happens? It is always a broad from the bottom, and then it thins down. So why it thins down? So that the broader part of the base gives you a huge surface area. And moreover, what you see is only the lower part. If you see it underground, which you can't see, the underground part will be much broader. That is the base, which is the base of the building, which will be foundation of the building, which will be much broader than the upper part of the building. Okay. The next is, porters wear turban on their head when they have to carry heavy loads. This helps them to increase the area of contact so as to reduce the pressure on the head and doors. Now, see, it's a very simple thing. If the porter is going to carry your bag directly on his head, the head and the bag will have a very small surface area, because head is like this and the bag is going to be like this. So there will be only like this much area of contact between the thing. So what he does, he takes a turban and wears it over here. So when he wears a turban, so he is getting the surface area of the complete head. The complete head surface area is available to him, because that is going to make it rest the whole bag on it. So since the surface area in contact between the bag and the head increases by the turban, so the pressure decreases. So porters wear turbans on their heads when they have to carry heavy loads. This helps them in increasing the area of contact so as to reduce the pressure on the load on their head. We move to the next one is, school bags and shopping bags have broad straps or belts so that the area of contact increases, the pressure on the hand or shoulder is reduced. You must have seen many times that the new bags what you are wearing, it will be, however we load it, you don't feel the load too much over here. But when you try to hold it in your arm, in your hand, you may find it very, very heavy. Why is it so? But because when you put it in your shoulders, first of all, you're having two straps, and those straps are big. The bigger straps, what they will do is, it will increase the surface area in contact between your shoulder and the body and the bag. There is the surface area is increasing. So the thrust of the bag is going to be appearing, or is going to be applied on a broader belts. If the same belt would have been very thin, it is going to pierce, it is going to hurt. Like for example, if you are going to carry a bag which is like a plastic bag which has got only some very small area in contact, so you'll find that it is hurting you. But the same thing if it is like a strap or it is like a cushion part over there, then it is easier to handle. And that is why you must have also seen many people that when they want to hold something for a longer period of time and they are having sharp edges, they put a handkerchief, they will put a handkerchief like this and ऐसे करके उसको ऊपर रखेंगे, and then they will handle it. So they will hold it with the handkerchief. Why would they do that? By putting that handkerchief, they are increasing the surface area between the belt and the hand. So this way you see that the straps, the increases or the belts increase the contact area of the contact area, and hence the pressure on the hand and shoulder is reduced. The next example we see is about the trains, the tracks of the train. You must also always see that the tracks of the train has got wooden sleepers on it. So the tracks are like this. These are the tracks. There's one track, the second track, and between them, at the lower part will be such wooden planks. Okay, there will be wooden planks over here. So which are, this is a track. This is a track. So this wooden planks over here, what they are doing is, if this wooden plank would have not been there, this rail, when the train is passing on this thing, this itself will exert so much pressure on the ground that this whole track will sink into the soil. Right? Because the whole pressure of the train when it is traveling, the whole body of the train, all the people who are inside are going to exert pressure on this particular small rails. So what they do? They are given the sleepers. These are called as wooden sleepers. So the whole pressure is distributed to this whole area, this whole area, this whole area. So as the train passes by, the whole planks over there, whole wooden planks over there are going to distribute the area, distribute the load, distribute the complete force or the thrust acted by the train on the ground, and accordingly by distributing this particular force they are decreasing the pressure which is exerted by the train on the surface, and hence the track is not sinking into the soil even after numbers and a huge number of trains passing through that same place regularly on daily basis. So wide wooden sleepers are placed below the railway tracks so that the pressure exerted on the rails on the ground becomes less. So this was how we see we are increasing the area so that the pressure is decreased. Hence we can define or differentiate between thrust and pressure. So we say pressure is the thrust acting on unit area. Pressure is the thrust acting on unit area, whereas thrust is the total force acting perpendicular to a surface. So the force acting perpendicular to a surface is thrust, whereas thrust on unit area is pressure. Pressure depends on the area on which the force acts. So pressure is dependent on the area on which the force or the thrust is acting on, whereas thrust is independent of the area on which the force is applied. Thrust is not dependent on the area on which it is applied. Thrust is just thrust. My body, whether I am standing on my one leg or I am running on two legs or I am sleeping or standing, the thrust is going to remain the same. But the pressure is not going to remain the same in all those conditions. Pressure will be higher if I am standing on my one leg or in my toe, or I am standing on both my legs, it will be much lesser. If I am sleeping, it will be least. The next is the SI unit of pressure is Pascal or Newton per meter square, whereas the SI unit of thrust is Newton. So this was about the pressure part of the chapter, and we see the next part is liquid pressure, which is completely different. So I think we'll better take it in the next video. So we'll stop over here. So next video will be about liquid pressure, and I can also see there are some numericals in this particular case. So we can also have a video based on the numericals over here. So we need not take the numericals which are the solved examples here, but the numericals which are there in the exercise part. There are 13 numericals in the exercise part. We'll take up those numericals in also upon another video. So my next two videos in physics will be based on liquid pressure, that the complete explanation about the liquid pressure, and secondly will be upon the numericals of this chapter. Okay, so that was physics for standard 8.